In episode 14, titled 1.5 Explain AI Concepts, Generative AI, LLM, NLP, Deep Learning, RPA, the goal is to make common AI terms sound like plain work language instead of mystery words. These concepts show up in data roles because teams are being asked to evaluate new tools, interpret their outputs, and explain risks to non-technical stakeholders. The exam angle is usually not to turn someone into an AI engineer, but to confirm that the language is understood well enough to make safe choices and to avoid confusing one capability for another. Clear definitions also prevent a common failure mode where a project is promised as AI, while the actual need is simple automation or a basic classification model. The core theme is meaning over hype, because meaning is what supports correct decisions and trustworthy reporting. Generative AI can be defined as systems that create new content based on patterns learned from existing examples, rather than only selecting from a fixed set of stored answers. The output might be text, images, code, or summaries, and the key point is that the system produces a fresh response that did not exist as a single stored record before the request. This is powerful in business settings because it can draft content, rephrase explanations, and generate variations quickly, which can save time for first drafts and repetitive communication tasks. The same power creates risk because generated content can sound confident even when it is inaccurate or incomplete, which is why evaluation and human review still matter. When a scenario mentions drafting, summarizing, rewriting, or creating new text from instructions, it is usually pointing toward generative AI as the concept in play. A large language model, often spoken as LLM, is a type of model trained on very large collections of text, so it learns statistical patterns in language and can produce likely next words in a sequence. The practical meaning is that an LLM becomes good at predicting plausible language, which makes it useful for answering questions, summarizing documents, and generating explanations in natural prose. Training on large text corpora gives it broad coverage of writing styles and topics, but it does not automatically give it reliable grounding in the specific facts of a particular organization or the current state of a system. An LLM can be tuned or paired with retrieval of trusted documents, but the core capability is still language generation based on learned patterns. When a STEM describes a conversational interface, automated drafting, or summarization driven by prompts, LLM is the central term. Natural language processing, often spoken as NLP, refers to methods that work with human language in a more analytical way, especially when the goal is to extract meaning, categorize text, or support structured decisions. NLP includes tasks like identifying entities, classifying topics, detecting sentiment, and converting free text into features that can be measured. Some NLP systems generate language, but many are focused on labeling and extraction rather than writing new paragraphs, which is why the distinction from generative systems matters. In data work, NLP often connects to operational questions such as why customers are contacting support, what themes appear in feedback, or which messages indicate risk or urgency. The exam often expects recognition that language can be treated as data, but only after methods are used to turn text into something that can be summarized responsibly. When a scenario mentions analyzing comments, tickets, transcripts, or emails for patterns, NLP is usually the intended concept. Deep learning can be defined as a family of modeling approaches that use multiple layers to learn patterns from data, often achieving strong results when the relationships are complex and hard to express with simple rules. The deep part refers to layered representations, where early layers learn basic signals and later layers learn more abstract patterns built on those signals. Deep learning is used in vision, speech, and language tasks because these domains have rich structure that traditional methods often struggle to capture without heavy manual feature design. The trade-off is that deep learning typically needs more data, more compute, and careful evaluation, and the resulting models can be harder to explain in simple causal terms. When a scenario emphasizes complex pattern recognition in images, audio, or large-scale text, deep learning is the broad concept that ties those capabilities together. Robotic process automation, often spoken as RPA, is best defined as rule-based automation that carries out repetitive tasks by following explicit steps, usually across applications and user interfaces. The key point is that RPA is not primarily a learning system because it does not discover new patterns from data in the way many AI systems do, and it typically behaves deterministically when inputs match the expected format. RPA is useful for stable, repetitive workflows like moving data between systems, copying values, generating routine reports, or triggering notifications based on clear conditions. The risk is brittleness, because when screens change, inputs vary, or exceptions appear, the automation can fail or produce incorrect outcomes unless it is maintained carefully. When a STEM describes repetitive clerical work and the desired outcome is speed and consistency rather than intelligence, RPA is often the correct term. A common confusion is treating prediction and generation as the same thing, even though they support different business outcomes and different risk profiles. Prediction usually means estimating a label or a number, such as whether a ticket is high priority or how many units might sell next week, and the output is evaluated against known outcomes. Generation usually means producing content, such as a draft response or a summary, and evaluation often includes usefulness, tone, and factual alignment with trusted sources. An LLM may use prediction internally to generate text, but the product behavior is content creation, not simply assigning a class label. This distinction matters on the exam because a question might describe a need for categorization where generation would be unnecessary and risky, or a need for drafting where a classifier would not meet the requirement. Clear separation prevents over-engineering and prevents selecting a tool that does the wrong kind of work. A support ticket example can make these concepts feel concrete because tickets contain both structured fields and unstructured language, and they flow through real operational processes. In a ticket system, generative AI might draft a proposed reply to a customer based on the ticket text and a knowledge base, helping an agent respond faster while still reviewing the output. An LLM might summarize the ticket thread and propose likely next steps, which can reduce reading time for escalations and handoffs. NLP might classify tickets into categories like billing, outage, or account access, and it might extract entities like product name or error code to support reporting. Deep learning might be used behind the scenes for more complex language understanding at scale, especially when tickets include diverse phrasing and noisy text. RPA might route tickets to the right queue, open a case in another system, or attach standard logs when a known condition is detected. Risks should be named plainly because they shape when these tools can be trusted and how results should be used. Bias can appear when training data reflects historical inequities or uneven coverage, leading to systematically worse performance for certain groups or certain language styles. Hallucinations can appear in generative systems when they produce plausible but incorrect details, which is especially dangerous when the output is treated as fact rather than as a draft. Data leakage can occur when sensitive information is exposed through prompts, logs, or training, or when a model output reveals information that should not be shared. These risks matter in exam scenarios because the best choice is often the one that includes validation, governance, and appropriate human oversight rather than the one that promises full automation. A mature framing is that AI can accelerate work, but it can also amplify errors if controls are weak. Choosing when to automate versus when to assist humans is one of the most practical decision points because it links capability to accountability. Automation fits best when the task is repetitive, rules are stable, and errors are easy to detect and correct, which is where RPA tends to be a good fit. Assistance fits best when context and judgment matter, such as drafting a response that must be accurate and aligned with policy, which is where generative tools can help but should not replace review. Some problems are best solved by prediction without generation, such as sorting tickets by likely urgency, because the output can guide attention while leaving final decisions to people. A common professional approach is to use AI to reduce effort on the first draft and the first pass, then require human confirmation for actions that carry customer, legal, or security impact. The exam tends to reward answers that respect this boundary between speed and responsibility. AI outputs should be connected to evaluation metrics and validation checks because trust comes from measurement, not from confidence in a demo. For prediction tasks, evaluation often uses error rates and confusion patterns, meaning how often the system is right, how often it misses critical cases, and how often it raises false alarms. For generation tasks, evaluation often includes factual checks against trusted sources, consistency checks against policy, and reviewer scoring for usefulness and clarity. Validation should include testing on new data, not only on the same data used to build the system, because performance often drops when real-world language changes. Ongoing monitoring also matters because behavior can drift as data patterns shift, and drift can make a once good model unreliable without obvious warning. In exam terms, a strong answer pairs A, I use with checks that make performance visible and defensible. Governance becomes central when data is sensitive or regulated, because tool choice is also a choice about where data flows and who can see it. Sensitive ticket text can include personal data, account details, or incident information, and those details may be subject to retention rules, access controls, and audit expectations. A safe design limits exposure by applying least privilege, controlling what content is sent to external services, and keeping records of what was processed and why. Governance also includes making sure outputs are labeled appropriately, such as marking drafts as drafts and ensuring users know when content was generated versus authored by a person. In regulated environments, the bar for explainability and traceability is higher, which often pushes teams toward assistive use and tight validation rather than full automation. Exam scenarios that mention privacy, compliance, or regulated data are usually signaling that governance constraints should dominate the decision. A simple glossary that can be recited helps keep these terms stable under pressure, because stability is what prevents mixing concepts during fast exam questions. Artificial intelligence, AI, can be treated as the broad umbrella for systems that perform tasks associated with human-like reasoning, including learning and pattern recognition. Generative AI is the part that creates new content, and a large language model, LLM, is one common engine for generating text based on learned language patterns. Natural language processing, NLP, focuses on working with human language for tasks like extraction, classification, and analysis, even when no new paragraphs are being generated. Deep learning is the layered modeling approach often used for complex pattern learning in language, vision, and speech. And robotic process automation, RPA, is rule-based automation for repetitive tasks. When these definitions stay consistent, tool choices become easier to justify and easier to explain. To conclude, the most useful skill is being able to explain these terms in work-focused language and connect them to the right kind of task and the right kind of control. Generative AI creates new content. LLM describes a model trained on large text corpora to produce language. NLP describes methods for analyzing and working with human language. Deep learning describes layered models that learn complex patterns. And RPA describes rule-based automation of repetitive steps. Separating prediction from generation reduces confusion, and the support ticket example shows how these concepts can appear together while still serving different roles. Risks like bias, hallucinations, and data leakage shape where human review, validation checks, and governance boundaries must exist, especially when sensitive information is involved. One practical next step is to pick one term, such as NLP or RPA, and explain it to someone today in 2 sentences that include a definition and a realistic use, because that habit builds the clarity the exam is designed to confirm. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.